we have a circle with center O. This is the circle with center O. We also have a sector with center A. And this is the sector with center A within the circle itself. So the dimensions are given. The first question will be show that the length of AB is approximately 17.9 cm. First, we need to assume few things. First, we have to assume that OA lies on the same straight line. This is the only way that you can solve out. Okay, this must be a straight line. Hence, we have a right angle triangle here. Can you see the right angle triangle? So right angle triangle will split a chord. When it form a 90 degree here, it will split a chord into 2 equal half. That will be 8 cm here. And if you have a look on a smaller right angle triangle, for the smaller right angle triangle, there's a dimension of 8, 10, and there's an unknown x here. So if I want to figure out the unknown x here, I can use Pythagoras theorem. 10 square minus 8 square with a square root, the answer will be 6. So the dimension here will be 6, EO will be 6, and since OA is a radius, OA is same as OB, 10 cm. Okay, so from a smaller right angle triangle, you can build a larger right angle triangle with the following dimensions: B, E, A, right angle, BE is 8 cm, EA 6 plus 10, so we have 16. Okay, so your task is to find the length of AB approximately, so we can just use a Pythagoras theorem as well. So the length of AB same as square root of 8 square plus 16 square. What do we have? We have 17.889. I always give more numbers, then I round it off to 17.9 cm. Okay, so make sure you draw a smaller right angle triangle, then from there you can form a bigger right angle triangle. Okay, so that is for question 1. Let's have a look on question 2. Okay, question 2, this is the shaded region. In order to find the perimeter, meaning we need to find the length of arc BED and BCD. Okay, so just make use of the formula itself meaning we need to figure out the angle here. Okay, so build the smaller triangle just now, as we know. Probably I need some of the information here. Okay, I just leave it there. Okay, in order to figure out the arc here, I need to know the angle here. So I'm trying to find the angle here, the angle over here. So let's label this as theta. Okay, so sine theta equals to 8 over 10. This is O, this is H, right? So sine theta. So theta equals to sine inverse 8 over 10. Make sure your angle input is in degree mode. 53.13 degree. So this is 53.13. Then let's say we have 2 parts of it. Okay. Then we times 2, right? Okay, now we have the angle here. Okay, now we have the angle here. 53.13 times 2 times 2, 106.26. The angle here is 106.26. Then we can find the arc. First, you have to be clear. For the circle center O, this is the arc. Let me draw it for you. This is the arc. The arc is not BED. The arc is BCD. This is the arc. Okay, so let's find the arc of BCD. So BCD arc in degree, right? Okay, and then I use max formula. Angle BCD equals to 2 pi r times 106.26 over 360 degree. This is our arc length formula in the angle input of degree. So I have 18.55 for arc BCD. Okay, now I need to look at sector ABED. In order to look for this arc length of BED, I need to know the angle here. Okay, remember, angle at the center is always twice the angle at the circumference. So this one should be 53.13. So now if you have a look on the sector of ADEB, these are the sector. Okay, then I use max formula as well. Angle BED, arc length BED. 2 pi, the R here is the length of AB 17.9 times 53.13 over 360. So 16.59, so 16.60. Okay, so we have the length of BCD, we have the length of BED. Now you can find the perimeter, just add up together. So the perimeter will be 18.55 plus 16.60. What do you get? You should get 35.15 cm. That is the question 2. That's for question 2. Perimeter of the shaded region. Okay, you can have a look, can have a snapshot and overview. Now the last part is the area. So I'm going to lump some of the things here. Okay, area. Let me think about that first. How do I find area? Probably I need to find the area of the sector BCD plus triangle BOA plus triangle AOD, the whole thing here, minus the sector of AOD. Then I have this shaded region. Correct. One more time. So I have the area of this sector plus the triangle here plus another triangle here, basically the area of the whole diagram here, minus the area of sector ABD, that is the shaded region. Okay, so now let's work on the sector first. Area of sector OBCD. Sector formula in degree, right? So pi r square. What is the angle idea? Forgot. 53.13 times 2. 106.26. Okay. 106.26. Okay, this is the area of OBCD. Sector lah, huh? Pi 10 square times 106.26, 333.82. Oh, over 360 degree. $92.73. Okay, that is the area of this part. Now I'm trying to find the triangle BOA. These two should be congruent. These two triangle BOA. Oh, so I need to split it to two parts first. Okay, do I know the angle here? Yeah, I can figure out. 360 minus this divided by 2. Okay. So 360 degree minus 106 divided by 2. I need to find the angle over here. Call it as theta. $126.87. Why? Because I want to apply the 1 over 2 AB sine C for triangle. AB also 10, 10, right? 10, 10 radius. So AB sine C, the angle, the included angle. And since there are two of them, so I times 2. So this is the area of triangle of BOA and also DOA combined together. 2 times 1 over 2 basically is 1. Not significant. 80 lah. So I have 80 cm square for both triangle. So the area of the whole thing here, it should be 92 plus 80. Okay, now I'm trying to figure out the sector of this red color sector, the red color sector with center A. Okay, red color sector degree also. Okay, so pi r square times 53.13 over 360. $148.58. Okay, so this one plus this one minus this one, that's the answer. Why? This one is this part. 80 is both triangle, so basically the whole thing here, minus 148. 148 is this part, so this is the shaded region. Okay, so one more step. The final answer, shaded area 92.73 plus 80 minus 148.58. $24.15 cm square. That is the answer for question 7. We have a semicircle with center O. We also have sector with center A. Alright. First questions, find the sector of COB. COB, just apply the formula. If you want to find the area, that will be 1 over 2 r square. R in this case is 8 cm. So 8 square of the theta. The angle here is 1.2. So just put it in. Very simple and straightforward. 38.4 cm square. That's the first answer, right? So the area of this part is 38.4 cm square. COB. Now we have a look of angle area of CAD. CAD. So meaning we have a look on this center. This center is a sector. Center A, the sector over here. So you need to know the radius here. This is the radius. And then you need to know the radian here. So how do we know the radius here? You need to know the angle here. This 1.2, this 180. 180 in terms of radian is pi. So this is pi minus 1.2. Okay, that is the angle here. And then in order to find the radius of this sector, which is AC, you can use cosine rule to find AC. So AC equals to square root of x square plus x square minus 2bc cos bracket pi minus 1.2. So make sure your angle input is in radian. Make sure your angle input is in radian. You should get 13.21 for length of AC. So this is the radius of sector ACD. So radius is not enough. You need to know the angle here. Since this is an isosceles triangle, this is pi minus 1 over 2. You can figure out these two parts. So the angle here, it should be 1.2 divided by 6, 0.6 didn't right? 0.6. 0.6, 1.2 plus here, the whole thing, it should be pi. Okay, 1.2 divided by 2 lah, 0.6. So 0.6 will be the angle for this sector. So same thing, 1 over 2 r square, 13.21 square with 0.6 radian. Find 2.35. cm square. Okay, now we have the area here. We have the area of this whole thing. You need to find the shaded region. Okay, let me plan a bit first. Shaded region. Okay, to find shaded region, maybe I can find area of this sector plus the area of this triangle. Right? So total area of these two parts. Total area of these two parts minus the area of this sector. That is the shaded region. Correct. Okay, so do we have this? Okay, we have this already. 38.4. Do we have this? No. So you need to figure out this part, the triangle. Okay, so triangle 1 over 2 AB sine C. So AB x cm each. C is pi minus 1.2. Okay, let's see. Sine C, right? So make sure your angle input is in radian as well. 1 over 2 AB sine C. $28.29.825. Okay, the area here 38.4 plus the area here 39.825 minus the area of sector minus this. That is the shaded region. So final answer, shaded region. I have this part 38.4 plus this part, the triangle. 38.4 plus 29.825 minus the sector here, this one. That will be the final answer for the shaded region. What do we have? 29.825 minus 52.35. You should get 15.875 cm square, and that's the final answer, which is the shaded region, the area of this part. Okay, we have a sector OACB with a center O, and this is angle 2.5. These are parallel. Show that angle AOC, this part is 5 minus pi radian. Since it involves parallel line, it's always good you extend the line so that you can see in a bigger picture. Okay, so this is 180 degree. That will be the same as pi radian. This is 2.5. Hence, this will be pi minus 2.5 radian. So pi minus 2.5 because of alternate angle. So this will be pi minus 2.5 radian. If you pay attention to this triangle, it's an isosceles triangle because these two are the radius. So equal length, equal angle, right? So if this is pi minus 2.5 alternate angle, this should be pi minus 2.5 as well. So if you're looking for angle AOC, or we call it as theta, you just have 2.5 minus pi minus 2.5. So for the part A, I will have 2.5, the angle of these two parts, minus the angle here, pi minus 2.5. So the final answer should be 5 minus pi radian. Solve. Okay. Given that the radius of a circle is 12 cm, 12 cm, 12 cm. Let's label it as 12. Find the area of shaded region. Quite simple. So I have area of the sector minus area of triangle, then I have area of the shaded region. So what is the area of the... Okay, let's apply the formula. Area of sector ACO, 1 over 2 r square, r is 12. The angle is 5 minus pi, so you have 5 minus pi. Okay, so this is area of sector minus area of triangle, 1 over 2 AB, so AB both are 12, so 12 square, sine an angle here, 5 minus pi. Make sure everything is in radian input. So area of sector minus area of triangle, radian mode. Final answer, it should be 202. Did I write something wrong? There should be something is wrong. Cannot be so huge. 1 over 2 r squared theta, 5 minus pi, (1 over 2 times 12 squared times 5 minus pi minus 0.5 times 12 squared times 5 minus pi. I key in my answer wrongly. So you should get 64.76 cm square. That's the answer for shaded area lah. Okay, then what else? We have the last question, the perimeter of the shaded region. So we need to find the arc here, so we can use r theta. We need to find the length here, we can use cosine rule. Okay, alright, so let's work it out. First, we find the angle of arc AC. Arc AC, you refer to r theta. R is 12, theta is 5 minus pi. So I have R12 and then I have 5 minus pi. That is the arc AC. 22.30, that is the arc AC. So now I need to find length AC. Length AC cosine rule. So AC. So maybe here. AC equals to square roots of 12 square plus 12 square minus 2 bracket 12 and 12, 2 PC, cos 5 minus pi radian. Okay, let's see what is the length of AC. 19.23. Okay, so 22.3, 19.23. Final answer. Perimeter of shaded region, 22.23 plus 19.23, 41.53. Perimeter of the shaded region. We have a sector OML, we have a center O, we have a tangent LN. So tangent mid radius, so we have 90 degree here. Therefore, this is a right angle triangle. Okay, this right angle triangle with label as LON, just for better visualizations lah, huh? Okay, now first, everything is in unknown, r, theta, perimeter is P, the shaded region, area is A, shaded region, in expression in terms of r and theta for perimeter. Okay, so in order to find the perimeter here in terms of r and theta, three different lines, right, surrounding this shaded region. The first line is line arc LM. Arc LM, we just use r theta formula. And yeah, so it's r theta. Nothing much lah, huh? The radius and the angle. So this is known as r theta. Ln, how do we find the length of Ln? You can have a look on this right angle triangle here. Since this is a right angle triangle, and we know that this is theta, this is r, this is let's label it as no, you are finding the angle, you are finding the length here, right? Ln. So this is your O. This is your A, OA. So 10. So you have to make use of 10. Tan theta equals to Ln over R. You are finding just Ln. So Ln equals to R tan theta. So R tan theta will be Ln. Okay, so now this is R theta. This is R tan theta. Okay, one more thing. You know the length here. Okay, the length here will be the same as ON. So there are few things we can do. We can make full use of this angle also. So if you want to find ON, let's call this as X lah, huh? To make you less confusing. So I let X to be Ln. I let Y to be ON. Okay, so I label this as Y. So if I want to find ON, I will have to use H. This is AH. So cos theta equals to R over ON. ON equals to R over cos theta. Okay. So now we have everything, right? Okay, if I want to find perimeter, in expression, this one, r theta. So r theta plus ln r tan theta. The last one, mn. Nn will be the same as on minus this part. This is r. Okay, so the last one, it should be on, so r over cos theta minus r. Okay, this is r cos theta minus r. That is your mn. That's why we have this. Is there anything else that we can simplify? No. This is the final answer for perimeter for question 1. Okay, so now we have a look on the area. How do we find the shaded region? The area of the shaded region. We have the area of the right angle triangle minus the area of the sector. I think I need to label first. R tan theta. Okay, I'll lap off now. Okay, just now this is R tan theta. Okay, should be okay. Okay, so area of right angle triangle 1 over 2, height r, base r tan theta, minus 1 over 2, area of sector r square theta. So this is how you express it. So can we simplify further? Yeah, maybe you can just combine these two into r square. So r square tan theta, 1 over 2 r square tan theta minus 1 over 2 r square theta. That is the answer for part 2. Okay. Now we have all the value. Okay, simple lah. Just sub in 1.2 and p equals to 82. Okay, we just sub in and then we find the value. Let me lap it off. P is 83. 83 equals to r theta. R is 1.2. 1.2 r plus tan 1.2. Let's see what we have. If I sub 1.2 here in terms of radian, oh, it's not going to be beautiful. I keep it first. I keep as tan 1.2 first, plus r over cos 1.2 minus r. Oh, so not beautiful. Oh, okay. But I think I can do one thing here. Oh, I forgot the r here. Okay, let me write again, everything. Okay, just use the answer here, is easier. I just change this one to 1.2, 1.2, 1.2. So 1.2 r okay, so the idea is everything with r, right? So everything with r, so I factorize this whole thing with r. When I factorize it, I have 1.2 plus tan 1.2 plus 1 over cos 1.2 minus 1. Yeah, okay, it's more beautiful this way. Equals to the p is 83. Therefore, okay, figure out the answer here from calculator, and then 83 divided by this, the answer of r. Let's see what we have. 1.2 plus tan 1.2 plus 1 over cos 1.2 plus 1 or minus 1, not plus 1. You should get 83 over 5.5319. R should be equal to 15 cm lah, huh? So that's the value for R. Okay, so R is 15 cm. I think we can find the value of A now. Okay, so number 4, the last questions. If you want to find the value of A, you just have to sub 1 over 2, R squared is 15, and then theta it is 1.2, minus 1 over 2, 15 square, 1.2. Let's sub in the value lah. Okay, let's see what we have. 0.5 times 15 square times 10, 1.2, minus 0.5 times 15 square times 1.2. Final answer, 154.4. 154.4 cm square. That should be the final answer for the shaded area. Okay, this is the overview. Alright, so we have a sector over here with center A. We also have another sector here with center C, and we have an isosceles triangle over here. Okay, so everything is labeled. First, we have to find the angle BCE and show that it's 1.287 BCE. This angle. Okay, to find this angle, maybe we can find this angle first. This is a triangle with 5, 8 labeled as the side. You can use cosine rule to find the angle here, or you can use right angle triangle. Because when I draw a right angle triangle here, I have a look on this right angle triangle. C, and I have A here, I have right angle triangle here. 8 cm isosceles divided into 2, so this is 4. This is 5. This must be 3, but it's not important. How do we find the angle here? These two angles should be equal. Staccato. Okay, so I label this as theta. OH sine theta equals to 4 over 5. Theta will be shift sine 4 over 5. Make sure your angle input is in. Oh, never mind. We can just keep the answer in radian. Shift sine 4 over 5. 0.927. Okay, so this is 0.927. This will be the same. You need to find the angle here. So angle BCE equals to pi 180 degree, because it's a straight line, minus 0.927 minus 0.927. So the answer should be 1.28759, and then you round it off to 2.7. Maybe you should give more here. Okay, we give more here. Shift sine 4 over 5 here. 92729. 30. Nine two seven three. Okay, then it's more accurate. 2.28699. Okay, and then you round it off, 287 radian. Exactly the same. Okay, so BCE here will be 1.287 radian. That is for question 1. Okay, now let's lop it off. Question number 2. Find the perimeter of the shaded region. So the length here, the length here, and the length here. Okay, just understand certain things first. First thing, this is XCM, radius of the sector, of this sector. Therefore, this should be XCM as well. It's a sector. This is 3 meter. And then there's another sector here. So this is 5. So this will be 2 meter. Okay. So I know the length here. I need to find the length of EB. Arc EB. Arc EB. R theta. R is 5. Theta is 1.287. 6.435. That's arc EB. How about arc DB? Arc DB, you need to refer the radius here, XCM, and the angle here. This is angle at the center, always twice of the angle at the circumference. So divided by 2, you get the angle at the circumference. So arc BD, R is 8, theta is 0.6435. 5.148. Okay, we have this. Perimeter of the shaded region. Two plus 6.435. $13.583 meter. That's the answer for shaded region. Okay, now we have a look on the last one, the area of the shaded region. Area of shaded region. We have the area of this sector plus area of this triangle minus area of this sector. Okay, that will be the shaded region. More or less the same, right? The past year questions. So area of this sector, 1/2 r square theta. Okay, this is done. Area of this triangle plus 1/2 AB sine C. Okay, so you have everything, right? 5/8 sine 0.46435 radian minus the sector of this sector, right? So the R is 8, and then the angle is 0.46435. Final answer 7.495, 7.5 meters square. That'll be the final answer for questions, the last question, shaded area. We have a sector of BCD. This is a sector with center B. We also have a sector of ACBD with center A, and we have a triangle ABC. Alright, three different shapes here. So the first thing is to show the length of BC. This one is 7.79. Okay, length, right? So just look at this triangle. Just look at this triangle. Okay, just look at these triangles. We know that this is 10, this is 10, 0.8 BC, cosine rule. So PZ equals to square root of 10 square plus 10 square minus 10 bracket 10 cos 0.8. Okay, don't write this answer straight away. You should correct it to two decimal places, so give it more. 7.78837, and then you correct to two decimal places, 7.79 cm. That is the first answer. So we know that BC, the length of BC, this one, now is 7.79. BC is the same as BD. Why? Because it's a radius. It's a radius for this sector, center P. So this one should be 7.79 as well. BD. Okay, now this one is done. Find the perimeter of the shaded region. Perimeter of the shaded region, need to know, first one is the arc BC. To know arc BC, you refer to this sector. Okay, let's work on arc BC. Arc BC, r theta, r is 10, radius is 10, theta is 0.8. So arc BC will be 8 cm. Okay, arc BC, this is 8. This is 7.79. So we need to know about this. So the arc. So to know this, we need to know the angle here. Have to use triangle again. Okay, let's use a triangle again. This triangle. To find the angle here, let's call it as theta. Opposite side is 10 cm. Okay, so let it be theta first. Sine theta over 10. Okay, this is one pair, this is another pair. 7.79 sine 0.8 over 7.79. So theta should be the same as sine inverse times 10. Right? We move this over times 10. .17. So the radian here should be 1.17. Enough already, no? You have everything already. Okay. So now you have length of BC. You have length of BD. Okay, you need to find the arc of CD. Arc CD should be R. R is 7.79. And then theta is 1.17. .1143. 9.1143. Okay. So this is perimeter, right? Perimeter of the shaded region. Arc BC 8. Arc CD 9.1143. Length of BD 7.79. So you have everything that you need to hit. You need to calculate for perimeter of shaded region. Final answer? (24.9 cm). That is for question 2. Okay, area of shaded region. Let's clear everything here. Or something maybe is important. Let me clear this part first. Okay. Perimeter of the shaded region. How do we find the shaded region? Area of the shaded region. So we will have to figure out the area of this sector. Okay, we have everything. And then area of this segment. Okay, segment. So area of these segments, we have to have area of this sector minus the area of triangle. Then we have area of segment. So area of this sector, label it again. Okay, area of this sector, 1/2 r square theta, okay, minus the area of this triangle, 1/2 AB sine C. So you have everything. AB sine 0.8 radian (4.13), quite small, right? So this part, it is 4.13 cm square. Okay, so now you have figured out the segment here. Just need to add the sector of this. So 4.13 plus the sector is 1/2 r square, 7.79 is the r. Theta is 1.17. I forgot a square. 39.6 cm square. That's the final answer for area of shaded region. So to recap, this one is 4.13. I have area of sector minus area of triangle. Therefore, the segment is 4.13. This part, it is area of another sector. So plus 4.13. The total answer should be the area of shaded region.